Hi all, today we'll be discussing the LeetCode problem of the day, delete columns to make sorted. So here you're given array of n strings of all same length. So the strings can be arranged one beneath the other to form a grid like follows. So we have A, B and C. The next string will be arranged below this B, C, E and then C, A, E. And it is guaranteed that all the strings will be of same length. So when we do this, we have 3 columns. Now you want to delete all the columns that are not lexicographically sorted. So in this example, if you look at the first column, which is column number 0, the string is A, B, and C. So this is lexicographically sorted. So this column is good. If you look at the column number 1, it is B, C, and A. So B, C, and A is not lexicographically sorted because after B it is C. I mean it is increasing. Then after C it's decreasing. So this column is not lexicographically sorted. And the final column, it is C, E, and E. So C to E it's increasing and E to it remains same. So this is also sorted. Now in this example, you have to delete one column. So your output will be 1. So return the number of columns that you will delete. Let's look at the example number 1. So we have C, B, and A, D, A, F, G, H, I. So first for column 0, C, D, and G, it is sorted. Then B. Okay. Next B, A, and H. So after B, it's again decreasing to A. So this is not sorted. Then you have A, F, and I. So this is lexicographically sorted. So you have to delete only one column. So the output will be 1. The next input is A in the first row, first string, and second string you have B. So in this you only have a single column and that column is sorted. So you won't have to delete any columns. So the output will be 0. And finally, let's look at the third input. We have Z by X, W, V, U, then T, S, R. So now column 0 is Z, W, T. So this is not sorted because it's decreasing. Then column 1, Y, B, and S. Same thing, it's again decreasing. Column 2 as well, X, U, and R. It's also decreasing. So none of the columns are lexicographically sorted. So we have to delete all the columns. So the output will be 3. In the constraints, we have n, which is the string length, and n can be up to 100. And each of the string length can be from 1 to 1000. And it is guaranteed that all the characters in the string will be lowercase English letters. Now let's go the approach. So here we have to exactly do what it is asked in the question. So we have to go over each column and check if it's lexicographically sorted. If it's not, then you just increase your count, and when you count all the columns, at the end you just return the count. So let's quickly code the approach. So we have count equal to 0. So this is the input is given as a string array. So for visualization, we are writing it one beneath the other. But if you want to iterate on the columns, so here you have 3 columns: column 0, column 1, and column 2. So first, let's iterate on the columns. So the columns will be equal to the string length. So in this case, the string length is 3. So we have 3 columns. And in column, we have 3 elements. That is equal to the number of strings. So now for each column, we have to check if it's lexicographically sorted. So we can use a function for that. Is sorted column. And pass the column number, also the string array. So if it's not sorted, then you have to increase the count. And at the end, return count. So now let's quickly fill the sorted function. This will return a boolean. If it's sorted, it's true. If it's not sorted, then false. Column and string array strings. So now you are, suppose you are checking for the first column. You want to check if all other strings, all the characters in this column is lexicographically sorted. So for that, you can start iterating from the first string and check whether this character is greater than equal to the previous character. Because if this should be in lexicographically sorted order, that means the current character should be at least greater than or equal to the previous character. So we can iterate from the first character equal to 1 less than, and so yeah, for it to be sorted, we should have string of I dot char at column should be greater than equal to string of I minus 1 dot char at column. So this is the condition if it's lexicographically sorted, but we are looking for the opposite case. So if it is not, that means if it is less than the previous one, we can directly return false because it is not sorted. So when the for loop is completed, if we never return false, that means the string is lexicographically sorted. So here we return true. Test it now. STRS. Same thing here as well. Then so it's a string, so we need to use length with brackets. Okay, let me submit now. Yeah, and it works. Finally, let's do the time and space complexity analysis. So for the time complexity, here we are iterating on the string length, and in the string length, we are iterating on the number of strings. So it will be overall n into length of string. And for the space complexity, we are not declaring any arrays, just the variables count and maybe the iterator I. So space complexity will be constant. I also have the code in Python. If anyone wants to review it, I'll add it in the description as well. And let's catch up in the next video.